All right, so in this example of expansion of trinomials, multiple polynomials multiplied together, okay, what we're going to do is we are going to take a look at each term in the first trinomial, and we're going to multiply that by each term in the second. So we're going to take this term first, and we're going to multiply it by this one. Negative 10t. Now that's a 2 there and a 2 there, so that's 4. Does that look right? Then we're going to go to the next one. And so that's going to be positive 4t cubed. Everyone see that? The third one, negative 2t squared, because that's just a 1. Now we move over to the next one. And you do the same thing. This one times the first one, and I'll just change the color here. So it's going to be plus 20t cubed. This is going to be minus 8t squared. And of course, times plus 1, just plus 4t. So we just keep doing this over and over and over until we're all done with the first polynomial. So here's the last term. So we need to do one more set of multiplication, then we can gather all the like terms. So negative 3 times 5 would be negative 15t squared. Negative 3 times negative 2t plus 6t, and then minus 3 in the very end there. Okay. So if we gather those terms there, all right. We look at t to the fourth. Is there another t to the fourth term? Nope. So we just recopy that, and there's nothing to combine there. Are there any other t cubed terms? Oh, I see one over there. Any others? Nope. Okay. So let's combine the coefficients for those. 4 plus 20 is plus 24 t cubed. Good. Now a squared term. Is there any other squared term? Oh, there's another one. Is that it? Oh, we've got one more here, don't we? Okay, so negative 2 plus negative 8 would be negative 10 minus 15 negative 25t squared. Remember, when you add, you don't change the exponents on the variables. Okay, when you add or subtract, don't change the exponents, only when you multiply or divide. All right, so are we almost done? I guess we have a 4t and a 6t. So what's that going to be? That's going to be plus 10t. And then do we have any constants left over? Oh, we have one constant there, so minus 3. Okay? So that should be our answer. Please make sure you circle your final answer. Whether it's factored form, if you're factoring, circle that, circle the factors, or if it's an expansion, circle that. Because there's going to be a lot of work, there's going to be a lot of steps. I need to know that you know what your final answer is, okay? And it just helps out when I'm taking a look at it. Okay, any questions there? Okay, that's example number 1. Now, there's another type of example that I want to show you that looks a little bit different, and it looks a little bit more complicated, but it's not really that bad, I don't think. But we do need to pay attention to what we're doing. So this is the second example here that I want to show you. So take a moment to copy this out, please. Okay, so for this example, I wrote this down on the side, bed mass. You guys remember what bed mass refers to? Okay, yeah, okay, so it's order of operations, right? Order of operations. So this is what, when we're doing a long string of different operations like multiplication, addition, and all that sort of stuff, there's an order that we have to do them in, or else we'll get the wrong answer. So the order here is brackets, B is brackets. So anything inside the brackets that we can simplify, we're going to want to do that first. Then exponents, if there's any exponents like to the power of something and we can evaluate that and simplify that down, we're going to need to do that next. Then division and multiplication can be done, either one can be done first, but those two have to be done next. So division or multiplication, whichever one appears first from left to right. And then addition, subtraction, same thing. Doesn't matter if it's subtraction then addition, but that grouping has to be done then last. So if we look at bed mass and we take a look at this, this right here, I see that I have an addition here that's outside the brackets. And so that means that this multiplication, okay, and this multiplication of 3 different terms, that has to be evaluated first, because the multiplication is actually the first thing that shows up on this list. There's no brackets because inside those brackets you can't simplify anything anymore. Those are unlike terms. There's no exponents, there's no division. So we have to do the multiplication first. So let's take that separately and we'll take a look at this. These are two binomials, so whether it's FOIL method that you remember or just distribution, I don't know how you think. If you think first, outside, inside, last, or if you just think let's just distribute, doesn't matter. So if we multiply those out, we get 2c squared, right? Plus 10c minus 3c minus 15. Okay? Does that look right? Okay, so that's just the first step. Let's keep going here. We'll simplify this later because this is still technically going to be in the brackets, and so we'll simplify that in a minute. And so we're going to add to that. Now we have to multiply three things. This is important, okay? On another example, if we had 2 times 3 times 4, okay, how you would evaluate that is you would simply do the first 2 times 3 is 6, and then multiply that result by the last one, right? That's how that works. You don't do this. You don't go 2 times 3 and then 2 times 4. We're not distributing in this case because each of those things are multiplied together, okay? So if you had 2 times 3 plus 4, then that's a distribution. But if you just have three things you're multiplying, you multiply the first two, you get that answer, then you multiply that answer times the third one. Get it? So that's what we're going to do here. Let me do one step at a time. So I'm going to take this first grouping and I'm going to multiply those together. That's 3c minus 9. You see that? And then I'm going to have to multiply it by this one. So really I have to do another step here before I can start adding up any like terms from both sides of the addition sign. Okay? So the next step, I'm going to simplify inside here. So really this is sort of still inside the brackets. So 10 minus 3 is plus 7c. So I write down that part. And we're going to be adding, now I have to complete my work inside the multiplication here. So this is going to be negative 9c squared plus 3c plus 27c minus 9. Does that look right? Did I miss anything there? Okay. All right, so we need to gather like terms here, right? Because technically now this is still inside the brackets. I still have to finish my multiplication, right? This whole simplification. We should simplify this first. You don't actually have to, but you could just drop all the brackets now and just go ahead and add everything from both sides. But we might do this first. Actually, you know what? Let's not do this first. I'll show you what you can do here. Now you can, because this is addition and you have all these separate terms, nothing is multiplied anymore. You can go ahead and gather all the like terms you want. Okay? So 2c squared, and then we have a plus a negative 9c squared. So 2 minus 9 is what? That's going to be negative 7c squared. Very good. So those two are gone. Sometimes I do this too. I just cross them out, and you can do that too. Once you've dealt with them, cross them out, move on to the next one. So 7c, is there another c? Oh, there's two other c terms here because we didn't simplify this yet. So 7 plus 3 is 10 plus 27 is 37. So that's plus 37c. Those are gone now. Everybody, is this making sense? Yeah? Okay. And what's left over here? I've got a constant terms and here. So negative 15 plus a negative 9, which is going to be minus 24. Okay. So there we go. We've got all of our terms gathered, like terms. Have we written these in the acceptable order? So we have the largest exponent on the variable first, then the next largest, and then the constant at the end. Yeah. So typically that's where you want to go there. Okay. So here's your answer, and of course you circle your answer, and then you're done.